Welcome back to the deep dive. So today we're looking at a problem that sounds almost impossible.
Right.
How do you send a perfect 4K video signal across basically the length of a football field?
Yeah, nearly 100 meters. Your standard copper HDMI cable just gives up way, way before that.
Exactly. So our mission today is to figure out how this DVI-Gear Hyperlight cable, the DVI-2590-AOC, actually does it. The source material calls it shattering limitations, which is a pretty bold claim.
It is, but I think it holds up. And the answer really comes down to this really clever hybrid design.
Okay, so hybrid. Let's unpack that. I'm seeing it's a mix of optical fiber and copper wire.
That's it. You've got 4 polyfluorinated optical fibers, the POF doing the heavy lifting.
And then 6 copper wires running alongside them. Now, wait a second. If fiber is so great, why even include the copper? Doesn't that sort of bring back the old problems of distance and interference?
That is the perfect question. And it gets to the heart of the engineering challenge here. The fiber is for speed, pure blistering speed.
How much speed are we talking?
We're talking up to 18 gigabits per second. That's more than enough for full 4K resolution at 60 hertz with, deep color.
So 4.4.48-bit, 4.2.2, 10-bit, all of that is covered.
All of it. The video data travels on light, but you still need the, let's call it the housekeeping data.
The handshake.
Precisely. That's what the copper is for. It handles the low-speed DDC communication, so your ED and your HTCP copy protection.
Ah, so the source device can actually talk to the display and know what it is, even from 90 meters away.
Without that reliable copper link for control, the picture would never even show up, no matter how fast the fiber is. It's what keeps it fully HDMI 2.0 compliant.
Okay, that makes so much sense. So beyond just the raw speed, what's the other big advantage of putting the video signal on fiber?
Immunity. Complete immunity.
From what?
RFI and EMI, radio frequency and electromagnetic interference. Because the signal is light, traveling through these optical channels, it has an incredibly low EMI profile.
And for you, the listener, that's a game changer in certain environments. Think about secure government buildings, hospitals with sensitive imaging equipment.
Absolutely. Or just any noisy electrical environment. It guarantees a rock-solid signal where copper might flicker or fail.
Okay, so the tech is brilliant, but what about the real world? How do you actually install this thing? High-performance cables are usually thick, stiff nightmares.
And this is the part that I think is the real aha moment. It's plenum rated, so it's safe for air handling spaces.
Which is a big deal for commercial installs.
A huge deal. But the kicker is the minimum bend radius. It's only 2 millimeters.
2? That's not possible. That's like a piece of string.
It's incredible. And it completely changes what's possible in an installation. Think about pulling cable through tight conduit.
Oh, yeah, a nightmare.
Well, the HDMI connectors on this are actually detachable.
No way.
Yeah. You take them off, and the cable's cross-section is just this tiny 12 by 10 millimeter rectangle, so it's super easy to pull. And it's tough. It can handle over 200 newtons of pulling force.
And I bet it needs a big, clunky external power supply to drive the signal that far.
You would think so, but no. It draws a tiny amount of power, less than 1/4 of a watt, directly from the HDMI source itself.
Wow. So no power brick to hide, no extra outlet needed. That just removes another headache.
Exactly.
So the big takeaway here is that you're getting extreme distance and noise immunity in a package that's actually, flexible, durable, and easy to install.
That's it in a nutshell. It solves the performance problem and the practicality problem at the same time.
Which leads to a really interesting final thought for you to chew on. We know the fiber handles the incredible speed for the video, and the copper reliably handles the slower but critical control data.
Right. The two have to work in perfect concert.
So the question is, how did the engineers tune that? How do you ensure that a low-speed electrical signal over almost 100 meters of copper arrives and syncs up perfectly with the signal traveling at the speed of light? It just highlights how complex maintaining that digital handshake is over such an extreme distance.